So hello everyone, welcome to the class. In this QA session 2, means the question answer session 2, we will solve more problems on RC first order circuit, right? So I think this video is going to be long, as there are four different questions we will try to solve. As you can see, this is the first question, this is the second, and this is third, and this is fourth. So don't worry, we will solve it one by one, and we will look the important concepts in each and every question. Okay, let's begin from question number 1. If you can see, okay, let me take this white color. Okay, so what are the, okay, you can see there is like, okay, there is one capacitor and the initial condition is given like it is charged to minus 5 volts, right? And there is a switch, and it is I think this will be closed at t is equal to 0. And here, okay, let me take one. Okay, and here you can see there is a dependent voltage dependent current source, right? So this is a current source, you can see, but it is depending upon the voltage. That's why it is dependent. I mean, this is a voltage dependent current source. There is a resistor R, 250 ohm, 250 ohm, the two resistor, and there is a voltage, DC voltage source 5 volts. So the question is, we need to sketch or find out the value of VC, right? Okay, so here in this question we will not take a very long approach of solving differential or integral equation. So we will, as we have seen in the previous lecture, that we will try to just see this those three things. The first thing was the initial condition, the steady state, and the time constant, right? Because this is a first order circuit, as you can see, there is only single capacitor, so only these three values will give us the complete solution, means like what is the value of VC, right? Okay, so let's start with the first thing. Okay, initial condition is given. Okay, so VC 0 minus is given like 5 volt, and this will be equal to VC of 0 plus, right? At the time of, means after this switching has been done, right? Okay, let's go for the calculating the steady state value of VC. Sorry, steady state value of VC we need to find. Okay, let's go for this. So in the steady state, what will happen? The capacitor will be charged and no current will flow through this that capacitor, and it will act as an open circuit, right? So okay, let's draw the circuit in the steady state. Five volts, right? This is again a resistor, this is a switch off, and here in steady state we need to find the value, right? This is VC, this node is VC. Let me take this node as ground, 5 volts, so this node will be again at 5 volts. This is 250 ohms, this is 250 ohms, and this is what is VR by 500, right? Plus minus, okay, this is given like VR, right? So here we will apply KCL at this node, means I'm talking about this node. We'll apply a KCL, right? So you all must be aware of how to apply KCL. Okay, so VC upon VC minus 5 upon 250, this is VR upon 500 already given, right? Plus what is this one in this node, if you see, okay, in this node, right? So I have taken this node, this branch actually, and this one. So this will be like VC upon 250, right, is equal to 0, means the summation of all the currents is going to be 0, and again that is equal to the incoming current is equal to the outgoing current. You all are aware of that. Okay, so what is, okay, VR and VC. See, so here this is equation number 1. So what is VR and, okay, again, see, if you see here, this is VR, right? And this node is at 5 volt and this is VC. So it's a very simple, like KVL, equation is there. 5 minus VR equal to VC, right? So 5 minus VC, 5 minus VC would be VR, right? I think this is equation 2. Let's put this equation number 2 in 1. So let's see what we will get. VC minus 5 by 250. Now if you can solve these steps quickly, then you can go forward and just, right, and you just calculate yourself. I'm going at a very slow pace. Plus VC by 250 is equal to 0. Just wait a few seconds. Okay, so if I just so this will be like 2 VC into 10 plus this is like 5 minus VC plus 2 VC is equal to 0. So what will 2 VC, 2 VC, 4 VC and 3 VC, right? And this is equal to minus 5, right? Equal to VC is equal to 5 by 3 volts, right? Again, this VC is what? This is VC, like VC at infinite value. Very like this VC infinite. We have calculated this VC for a steady state, right? So now we have initial condition. We have got this VC 0 minus is equal to 5 volts. Initial condition VC 0 minus is equal to VC 0 plus. This one is okay. VC is equal to 5 by 3 volts and the time constant. Okay, so how to calculate the time constant? Fine. So in time constant, what we need to do is we have to calculate the R equivalent across C's. This is the thing, is that there is only one capacitor, right? Here there is only one. Okay, there is only one capacitor here, right? So we need to find out how much capacitor means what is the equivalent resistance this capacitor is seeing, right? Means across its terminal, right? So for that, in order to calculate the R equivalent, we have to nullify the independent sources, right? So if it is a voltage source, it will be 0. If it is a current source, it has to be an open circuit, right? Now this is a dependent source, but we cannot means we will not make any changes in the dependent sources, right? Okay, so let me give you what I want to say. So this is like this one. We will not remove this. This was independent source, right? Plus minus. This was VR. This is 250 ohm. And again this is 250 ohm. And what? Okay, let's apply this voltage Vx and Ix. Right, now this Vx upon Ix will be like R equivalent, or you can also call it like RTH. RTH stands for Thevenin resistance, right? Again, so we need to find out this Vx upon Rx. So this one was like VR upon 500, right? So let's again solve the KCL at this node, at this particular node. If we apply KCL, and we will get this Vx upon Ix, right? So let's solve it. So this node voltage will be like Vx, because I have already assumed, I have taken this voltage as Vx. This will be like Vx. Okay, now Vx upon 250 plus VR upon 500 plus Vx upon 250, and this will equal to this Ix incoming current. right? Okay, so here you can see this is one branch, this is second branch, this is third one, and this is the fourth one. So first, second, third, and this is the fourth one, right? Okay, now again the relation between Vx and Vr. So what is this relation? Okay, this node is again, this is like ground. I am open to choose, means I am means free to choose this node as a ground voltage, 0 volts actually. So again 0 minus Vr would be Vx. So is it okay? 0 minus V. Okay, fine. Simple case. This is equation number 3. This is equation number 4. Right. So Vx is nothing but Vr is nothing but minus of Vx. So let's see, Vx upon 250 minus Vr upon 500 plus Vx upon 250 is equal to Ix. Let's sum. This is like 2Vx minus V. Okay, this we have made a mistake while teaching. It always happens actually. Vx, and this is like Vr. Vr is equal to minus Vx. Vr is equal to minus Vx. Okay. See. Okay. So, okay. This is like Vx plus 2Vx, right? And this will be 2Ix, and this would be like 2 to 4 and 3Vx upon 500 is equal to Ix, and Vx upon Ix is equal to 500 by 3 ohms. So now this is actually nothing but the R equivalent, or this is R equivalent, right? Or RTH. This is like Thevenin's or R equivalent, same, right? So the thing is that why I have, so the thing is that this capacitor C was looking actually this one, this resistance, right? So this was discharging like this way, or maybe charging or discharging, right? So if I remove this, so this will become the actual circuit. This C, this is C. Now the thing is that let's find the time constant. The third thing, time constant. Time constant tau would be R equivalent C equivalent. Here R equivalent is like 500 by 3. And what is C? What was the value of C? C is 0.6 microfarad. Okay, 0.6, or these are in ohms, right? 0.6 microfarad, 0.6 microfarad, and this is ohm. So 3 into 0.2, 0.2, how much? 0.2 and 1 by 5. This will become 100 microsecond. Now this will become 100 microsecond actually, because the unit is in the time constant has the unit of time, right? Seconds, 100 microseconds. So okay, this is tau. So our final equation would be Vc of t would be, as we know, Vc of infinity plus Vc 0 minus Vc infinity e power minus t by tau. So what was Vc infinity steady state? It was, I think, 5 by 3 volts, right? Plus Vc 0, it was already given minus 5, and minus 5 by 3 e power minus t by tau. Tau is equal to 100 micro. Let's write like this, and it will become 5 by 3 minus 20 by 3 e की power minus t, and it will become like 100 micro, 10 power 6 super 10 to power 4, right? So this is the solution, right? So let me take the shape. So this is the equation, and if I need to draw the graph, see. So the thing is, okay, initial voltage, let me say this is VC. So initially it was minus 5 volts, right? Minus 5 volt. In the steady state it was like 5 by 3 something here. Let's please actually forgive me, actually I'm not drawing to the scale, so but value is more important. My drawing is not that good. Okay, this is 5 by 3, right? Positive. So okay, if I draw like this, and again if I draw like this, and suppose this is my, okay, so it starts from minus 5, it will cross 0 at some point, and it will again approach to 5 by 3. So again, just what we have studied in the previous lectures was that if you see this time, this transient time, I think this is around after 5 time constant, this will achieve steady state value, right? 5 time constant means it will almost reach 99%, or 4 tau like 98%. So this is the graph, right? So again, if you need to only draw the graph, then we need not to calculate this third thing, right? Means equivalent resistance is not required. So only by just steady state value, means only just by initial conditions, and initial condition steady state value, we can draw the graph. But the thing is that it has to be first order circuit, then only you can just directly draw it, right? If it is second order, you cannot say, because in second order the dynamics is different. There are some overshoots kind of thing, overshoot, undershoot, right? So you need to know whether there it is, means like critically damped, over damped, under damped. So there are cases in the second order, but as you know, it is a first order circuit. Then using the initial condition and the final steady state value, I can directly draw it. Again, the source has to be constant, right? Here it is, the source should not be like a time dependent. It has to be in like a constant DC source, then only it will approach a constant value in the steady state, right? As you can see. So far so good. Okay, so here we have solved the first equation, sorry, the question number 1. Okay, let's go to question number 2, right? Okay, so here you can see, so the switch was, means this switch was positioned at, so there are two positions actually, position number A and position number B. So switch was there in position number A for a long time, right? And at t equal to 0, it was moved to position number B. And now they are asking, the question is saying that draw the sketch of IT again. So we can see, means here there are 3 different capacitors, but if you see there is equivalent capacitor, this will be only single capacitor. So again, this circuit is like first order circuit, and here again the source is constant source. So here what it is saying, sketch IT for t greater than 0. Okay, so the thing is that means here also the same thing is there, the initial condition, the steady state value, and the time constant, right? So since we want to go means we want to approach in a subjective way, so let's calculate everything, right? I'm not targeting any means competitive question, right? So let's solve it in a subjective way. Okay, so let's see what is happening before switching. So before switching, sometimes I'm taking white color, sometimes blue. Okay, hope this is not creating a problem for you. If it is, please again comment on it, right? I will try to improvise the way I am teaching. Right now my focus just to deliver the concepts. Okay, so just when the switch was only at position A, so there are capacitors. Again, how much? 100 volts. I don't know why do these questions give this 100 volts, or maybe I have written wrong. 10 volts is okay, 20 volts is okay, but 100 volts. Anyways, let's 0.2 micro, 0.3 micro, and 0.5 micro. So this was the case of when they before switching, right? So here it is, we can solve C equivalent. So it will be like, again, these, okay, again these two capacitors are in series, so it will become sorry, they are in parallel. So in parallel they will be added like 0.5 and 0.3, 0.8 microfarad, and again that 0.8 and 0.2 will be in series. So again C1 C2 upon C1 plus C2. So I am directly solving, right? So there is no concept involved here. 0.2 into 0.8, again this will be like microfarad unit, and 0.2 plus 0.8, नीचे 1 हो जाएगा, ऊपर 16. There are two, 0.16 microfarad. ठीक है, fine. So this will be like an equivalent circuit. So here I am just drawing in a this is 100. Okay, now it has reduced to a simple RC circuit. Actually all the questions will be reduced to a simple RC circuit. 100 volts, and this is 0.16 microfarad. Now the question says it is there for a long time. The switch stays at position 8 for a long time, means this voltage or this node of this capacitor, this upper node of this capacitor will charge up to 100 volts, right? Because 100 volt is there. Now it is switching to position B at t equal to 0. And this is what is this? Okay, let me draw the way question is given. Again, if I'm going slow, so you can watch it at 1.5x speed, right? Now initial voltage, this is, let me know, this is plus minus VC, right? And this is 5 kilo ohms, right? And what they're asking, okay, now here it is, and it was VC 0 minus is equal to VC 0 plus is equal to 100 volts, right? Now it is asking this I of t. So let's go, what is happening at I of, so what is I of 0 equal to? So I of 0 means, let's, okay, draw the capacitor was 100 volt charge, this is like 20 kilo ohm. So I of 0, so this will be like I of 0. I have drawn actually this circuit at t is equal to 0 plus. So this capacitor was charged to 100 volt, right? 100 volt. So I of 0 will become, this is I of 0 plus, right? I of, if somebody asks you what was I of 0 minus, I of 0 minus would be 0. Why? Because there was the circuit, the switch was at position A, right? Right. So here it will become 100 upon 20 kilo ohms to be 5. I think it will be 20 kilo ohm, 5 milliampere, right? Oh sorry, this is 5 kilo ohms. I am not paying attention to the values. Again, this was 100 and this is 5 kilo, right? So 520, so this will be like 20 milliampere. This is the initial condition, right? And what is the final value, I of infinity? I can see in the final state what will happen. This capacitor would be completely discharged, so current would be 0, right? Now let's find out the okay, time constant is very simple. What is the time constant? So initial condition I got I0 plus, final value I got, the time constant will be R There is nothing like equivalent R into C. So what is R? 5 kilo ohm, 5 kilo. And what is C? C was 0.16 microfarad. What is this solar purchase? 0.8 16 5 80 सोलर पचास, ठीक है. K into 10 पर मतलब 8 मिली सेकेंड्स, राइट. K into micro 10 to minus 3, 8 milliseconds. Okay, now the question becomes very easy. So the I of t will be, so I of t would be I of infinity. Infinity it was 0 plus I of 0, it was 20 milliampere, minus infinity e to power minus t by tau. Tau is 0.8 milli and this is like milliampere. So the current would be like 20 e to power minus t by tau. So 1000 ऊपर, इसमें एक्चुअली मिली, ऊपर 1000 हो गया एंड 8. सो व्हाट इज दिस? 8 10,000, राइट. 0.8 है 10,000, तो 125. This was like milliampere. Again, it is a matter of numerical solving. It's a matter of number. It is like 125 and 0 t, right? It's milliampere. I of t, and again it is for t is greater than equal to 0 response, right? Because this response is obtained after the switching. So if you see, this is the case, right? Okay. This is like question number 2. The same approach was there here. Okay, this is again the switch. Okay, let's go for question number 3. So here again switch was at position A for a long time, okay, and then at t equal to 0 it is moved to position B. Okay, and sketch VT for t. What is VT? VT, sorry, it is VCT. Okay, VCT for t greater than equal to 0. Okay. So this will be solved exactly same way, just like previous case. So let's go. Let's see what is the value of VC, right, before switching. So before switching, switch was at position A, right, and it was there for a long time, so that capacitor will reach a steady state. Let's draw the circuit. It's always good to draw the circuit. Plus minus, again DC source is given. This is 3 ohms, this is 2 ohms, right? This is 3, this is 2, I think ohm or kilo ohms, okay. And again this is capacitor here when switch was at position A. So here you can see 10 volt. So in the steady state, what will happen? This capacitor will not charge. This capacitor will not conduct because it is fully charged. So it will act as an open circuit, right? If it is an open circuit, so this will be a steady state, only this will be there, only this circuit will be there. So we need to find out the voltage across these two, right? These 2 ohms. Again, so it's a simple voltage divider. We have to apply voltage divider. So what is VC? Will be like it means 2 by 3 plus 2 into 10 volts. That is what? 5 to 4 volts. Let's check it. 3 into 5, 5 into 2, 2 into 4. Okay, 4 volts, right? Now this capacitor will be charged to 4 volts, right? And it will stay in equilibrium about 4 volts until the switch is moved to position B, right? Now see what is happening at position B. So for this capacitor, VC 0 minus VC0 minus is like 4 volts, right? ठीक है, 4 volts हो गया. And there is 4 ohm, 2 ohm. Okay, 4 ohm, this is 4 ohm, this is 2 ohm. Again there is our resistor, this is okay. Here the current source is given. Okay, I think we will learn some new concept here. Actually there is nothing like concept. Till now we were solving using a DC voltage source. Now it is like current source is there, constant current source. Okay, VC 4 ohm, 2 ohm, 2 ohm. Okay, I'm just revising. Okay, again I need to find out this value of VC. I have to draw it. Fine. So again initial condition for this capacitor is known. This is right. So VC 0 minus would be equal to VC of 0 plus is equal to 4 volts, right? Okay, now what will happen in the steady state, right? So in steady state what will happen, this capacitor will be charged to some volt. Right now we don't know what is that volt, but once it is charged it will not conduct, right? So what will happen, it will act as an open circuit. This is 5 ampere, this is 2, this is 2. See, so the thing is that no current will flow through this branch, right? So there is no meaning of this resistor, at least for calculating the steady state value of this VC. Now what will happen, all the current is passing is like this way, right? So it means at t is equal to for a larger time, all this 5 ampere will flow through this. Now you can see this 5 ampere is flowing through this. It means a voltage drop of 10 volts will be there, means 5 into 2, 10 volts. So this capacitor would be charged to 10 volts, right? It means at VC infinity would be 10 volts, right? Now this has become the second part. Means the first part was initial condition like 4 volt, the steady state value is 10 volt. Now let's find out the time constant. Again for time constant, what will happen, see in this circuit for time constant, so we have to find out the means what this capacitor is seeing the equivalent resistance, right, across the equivalent resistance across this capacitor. So for that we have to nullify the DC sources, right? So if there is a voltage source, we will see it will act as like short circuit, and for a current source it will act as like open circuit, right? So this capacitor will look like this. Okay, the circuit will look like this. ये open circuit हो गया. Now what is the resistance? R equivalent. This was like 2 ohm, 2 ohm, and this was 4 ohm, right? I think there was 6 ohm. It's simple. There are two resistors in series, so R equivalent would be 4 plus 2 is equal to 6 ohms. This capacitor, this 2 ohm resistor has no meaning because here it is an open circuit, right? Now this question is also solved. Tau is equal to C into R equivalent. What was the value of C? C was, what is the value of C? 0.1 farad. Achha, 0.1 into what is the value of R equivalent? 6. So 0.6 seconds. This is the time constant. Very large value of time constant is there, right? Okay, this capacitor is very large. That's why it's means this system has a large time constant, right? Okay, so now this question is like almost solved. This is I of infinity plus I of 0 plus minus I of infinity e power minus t by tau. Oh, this is all V, right? I'm sorry guys, absolutely sorry. So I'm not going to write the equation. So VC what was VC infinity? So at infinity we found out it was around 10 volts plus initial voltage was 4 minus 10 e power minus t by 0.6, right? Okay, so this will become 10 minus 6 e की power minus t by 0.6. This is the equation for t greater than equal to 0, right? So if you solve it, if you draw a graph, so it was starting from what? T is equal to 4 volts. Again, it was starting from t is equal to 4 volts and it is going to VCT 10 volts, right? ये ड्रॉ कर दिया, ये ड्रॉ कर दिया, and again 4 to, so it is going like this way. All the responses are looking like this in a rising manner, right? Okay, right. So again, just like other questions, it rises from the initial value and it approaches or it settles towards the final value, the steady state value. And again, the what is more important is like what is the what is the time of transient. So the time of transient is like 5 into tau, right? So if somebody asks you what is the transient time here, so means approximate, either it is 4 tau or 5 tau, I think maybe in the question they will give you 98% or 99% or some value, right? So roughly I will take 5 tau. So 5 tau is like 5 into 0.6, that is like 3 seconds. So after 3 seconds this system will settle down, right? So the transient time is like 3 seconds, right? So moving forward to question number 4, right? Okay, so this seems something good. Okay, so there is no switch here, so switching नहीं हो रही है क्या? VI, अच्छा UT, okay fine. So here we have to draw the response of V naught T. Actually it is not written. So sketch, this will be the last question of today's Q&A session. Sketch V naught of T. Right, this is something interesting. Fine. So all the, again, let me write it again here. Initial conditions are 0 for the capacitors, right? There is no initial conditions, otherwise I would have written here. Okay, so switching is not there, but in the question it is given that VIT is equal to 10 of UT. It means at T is equal to 0, like you can see, it is going like this way, right? 10 volts. This is like V of IT. So it means switching is there. Switching is happening. So before switching it was like all the capacitors were not charged, 0 volts, and let's see what happens at T is equal to 0 plus, because we need initial condition, final condition, steady state value, and then time constant, right? Okay, so before that, if I'm saying that it is means I can solve this equation using this 3 condition, it means it has to be a first order circuit, right? So is it a first order circuit? So okay, so just to see the first order circuit, let's means nullify the voltage and let's see what is given. ये हो गया capacitor, right? Okay, so let's take, this is R1, this is C1, this is R2, and this is C2. Let's name it. Naming is very important. C1, okay, and this is like C2, and this is like R2. Since we are nullifying the voltage source, it has to be okay. Is it a first order circuit? Okay, now this circuit will reduce like this. Here ये ऐसा C हो गया, right? Let's call it node A and node B. This is node A and this is node B, right? This is node A and this is node B. So all of them are means applied between node A and node B. All are connected between node A and node B. This is R1, this is C1, and again you see C2, node A, and this is node B, and R like node B. So you can see C2 and R2. The C equivalent would be, C equivalent is like these two are in parallel, C1 plus C2, right? And R equivalent would be R1 R2 upon R1 plus R2, because both R and C are in parallel. So for parallel, you know, this is equivalent resistance, and for parallel capacitor, both of them are added like this. So definitely again it is going to be like a simple RC circuit. As it is a first order circuit, right? So again we can, if it is a first order circuit, so again for solving V naught T, right, we can use this initial condition, final condition, and the time constant, right? And time constant is simply like this: T is equal to C equivalent into R equivalent, right? So let's solve right now. So what is C equivalent? So what is the 1 microfarad and 4 microfarad? So C equivalent is like 5 microfarad, right? And what is R equivalent? 1 kilo and 4 kilo ohm. So 1 kilo into 4 upon 1 plus 4, 5, ये हो जाएगा किलो ओम. Y equal to sign kilo ohm, right? I'm just calculating this R equivalent in a rough way. 4 by 5, 0.8 kilo ohm, right? 0.8 होगा ना, 1 से तो कम होगा. 1 और 4 पैरेलल में, तो 1 से कम होगा, राइट? ओके, 0.8 किलो ओम्स, 0.8 kilo ohms. So let's see, 5 8 40, 4 and kilo, 4 milliseconds, right? Micro and kilo is milli, 4 milliseconds. So here I have already calculated the time. The first means I have already calculated this time constant as 4 milliseconds, right? This was very simple. Now let's go with this initial condition, right? What is the value of V naught 0 plus? See, since the capacitors are initially not charged, so let's draw the value at t is equal to 0 plus. Very interesting question is there. Okay, this will be 10 volts. This will be like 0. This will be like 0. Okay, you see here, there's a magic kind of thing. Not magic, but something different, right? This was R1, this was R2. Why I have chosen that like this? Because the thing is, see, the capacitor, since what we have studied, that capacitor does not allow sudden change of voltage. Okay, so 0 volt पहले भी था, अभी भी 0 volt हो जाएगा across capacitor. This is C1, and similarly C2. Now you see there is a short circuit path. So there is a short circuit path, this one, and there is no meaning of R over here, right? Short. So in short circuit, what will happen if you apply Ohm's law? V is equal to IR and I is equal to V. V is like 10 volts and R was like 0. It will go to a infinite, means a very large value. It means for this special circuit, what will happen? The current will have, means at t is equal to, means at t is equal to 0 plus, I would be like infinite, and due to this, capacitor will charge instantly. The capacitor will charge instantly. See, resistors are definitely there, but not in the path of the capacitor actually, right? So there is no meaning of the resistors if capacitors form a short circuit path, right? Now if it is like this, so let's draw the equivalent circuit. Plus minus, only capacitor will be there in the circuit, right? This way. This is like only at t is equal to 0 plus, right? Because this is forming a short circuit path. Now I have to find out the voltage. This node was like V naught. So V naught of 0 plus, I need to find it out, right? What is this value? Right? Okay, so from the charge conservation principle, the initial charge will be equal to the final charge, right? So what was the initial charge? Initial charge, since the capacitor means this before applying the input, right? the capacitor was not charged. So definitely both the capacitors were uncharged. So I can write like this way: 0 plus 0, both were having 0 charge, right? Now at t is equal to 0 plus, this was at t is equal to 0 minus, right? Now at t is equal to 0 plus, t is equal to 0 plus, right? Again it has to be same, right? But the charge has distributed. So what is the value? Okay, so at this one, the magnitude, let's say the magnitude minus this is, okay, let's call it like this. So this was at, this is plus q, this was minus q, and this was again plus q, and this was minus q. So here if you see this is plus q. Okay, if you see this node, oh god, why this is happening? iPad also creates some problem. Wait, let me explain it. This is important. Okay, so if you am talking about this node, right? This node, particular this node. So initially it was having a charge of 0. After applying the input voltage, again it will have a charge of 0. Now the thing is that here, if it is having this plate, okay, let me draw like this. This is right. Now here it will be clear. This was plus, this was minus, this was plus, this was minus. If you see only this point, this plate, this area, right? This minus and this plus, again the effective charge again on this two plate is again a 0, right? So this is, that's why I have written this is minus q, this is minus q, this is plus q, right? This is plus q and this is minus q. So effectively if you look at this plate, right, net charge is equal to 0. Although voltage is developed, right, but net charge is 0, just like at t is equal to 0 plus, right? What? So at t is equal to 0 plus, the capacitor was not charged, right? But and again there was no charge. But here in this in the second case, both the capacitors would be charged, right? But the effective charge on these two plates would be 0. The net charge would be 0, right? Because if you see, these plates are isolated. You are not putting a charge from external source and you are putting here, right? At this node, right? So even after switching, this charge would be, the total charge present of this node will be 0, right? Okay. So what is minus q? The voltage difference will be like 10 minus V naught, right, into the value of C1, right, and plus what is this second one? This is V naught, and the charge is like V naught into C2, right? So basically what I have written, okay, here it is like minus q and here it is plus q, right? Minus q and plus q. That's why I put this minus sign. It's very important, right? This minus sign. Now if I solve it, 0 is equal to, right, what is there? Minus 10c1 plus v naught c1 plus v naught c2. So v naught would be 10c1 upon c1 plus c2, right? So what is the value? 10 into, what is the value of c1? C1 is 1 microfarad and C2 is 4. So this is like 1 microfarad and C1 plus 4. Micro will be cancelled. Like it will be like 2 volts. Right? So okay. So this is like V naught of 0 plus would be 2 volts. Right? So this is the initial condition. Right, for V naught. So what? Okay, now we have achieved this one. What will be at the final value? Again, the final value, in the final value the capacitor would be completely charged, right? Here this charge was present only at t is equal to 0 plus. This all means whatever we have solved over here, this charge was only present at t is equal to 0 plus, right? Again it will keep redistributing itself. right? Now at t is equal to infinity, what will happen? Both the capacitors C1 and C2 will be charged and no current will be there, right? And the circuit will be, okay, let me take a different color. Okay, this was like 10 volts, no? 10 volts, and only this resistor would be there. This capacitor is charged, open circuit. This capacitor is charged, open circuit. This resistor is there. This is R1, this is R2, and again V naught infinity at t is equal to infinite, means steady state, right? So again it is reduced to like a simple voltage divider circuit, right? So its value will be R2 upon R1 plus R2. It is too simple, into 10 volts. So what is the value of R2? R2 is 4 kilo ohm and this is 1 kilo ohm. Okay. So R2 is 4 kilo ohm and this is 1 plus 1 kilo ohm plus 4 kilo ohm into 10 volts. It will be like 8 volts, right? 8 volts. Now this question is solved, right? So if somebody asks, so what is the value of, means what is the behavior of V naught t? Simply what is the final value? 8 plus what is the initial value? 2 minus 8, right? E की power minus t by tau. Tau was, we have calculated, right? Tau was what? 4 milliseconds. 4 milli. It is like 4 milli, right? 4 milliseconds. So if you see 8, this is minus 6 e की power minus t, and 4 milli ऊपर 1000 और 4 25 25 चौका 100 250. So this will be like V naught of t would be 8 minus 6 e की power minus 250 t. मैं इसको, now if you see, this is the case, right? Now if you simply draw it again, so initially it was like 2 volts and finally it was 8 volts. This is 2, this is 8. Now the response would be sandwiched between these two initial and the final volts. It is a first order circuit, so again it is like going like this way. So again in the 5 time constants, 5 into 4 milliseconds, like in roughly 20 milliseconds, approximately 20 milliseconds, this transient will die out, and this is how the response will look alike, right? Now this question is very important, right? So okay, this is how you are going to solve the question. So the important part was this one, how, so let me give you a quick revision of this question. So the important part was how the capacitor was changing instantly. Till now what we have said, that VC0 minus is equal to VC0 plus, right? So this only happens, why? Because there is no infinite current or very large amount of current through the circuit. Generally a resistor is always there, means any charging current in the path of means if there is a path and there is a resistor in the path, so definitely it will take some time, it will not charge. Okay, so let me draw the graph actually, the circuit actually. Okay, so suppose this capacitor is charging, right? This is plus, this is minus VCT, right? Now if there is a resistor in the path of charging, right, 1 resistor, 2 resistor, or there may be n number of resistor, so it will not change its voltage suddenly, right? Just because this resistor, the presence of the resistor would limit the current, right? This will limit the current, and once it will limit the current, the capacitor will not it will not suddenly change the voltage across it, right? Because the charge will not suddenly have. But when this capacitor is alone in the path and there is only a voltage source like this, right, somehow, then this capacitor would instantly charge, right? Because no direct resistor is present in this in this path, as we have seen here. Let me show you. Okay, here as we can see, you see in the path of this resistor, in the path of this loop, there is no directly resistor which is coming, so it is not limiting the current. So in this case, when you apply a KVL in this circuit, you will see there is only this voltage source, there are two capacitors, right? It means so at t is equal to 0+, if you apply the capacitor, if it does not allow sudden change of voltage, it means this will be like I will be like infinite, right? Because there is only a single voltage source and no resistor in the path, right? So if there is no resistor, means V by R equal to like infinite value, right? So the key thing is that if there is no resistor in the charging or discharging path of capacitor, it means it will suddenly change the voltage across it, right? So this is the key point, right? Okay, so again, if you feel uncomfortable or you do not understand, please drop a comment so that I can make a special different video on particular this question only, right? Or this type of questions only. Or if you have a different type of questions, you can just post the image in the comments, so then I can just analyze it and tell it to you. Okay, so thank you very much for paying attention to this video. Okay.